Hello, this is lesson one of a five-part series on how to work with slope-intercept form. And first off, I want to start out with an introduction to ordered pairs and graphing. Now, you've all at this stage worked with graphing, worked with creating lines before. What I've got here is just a reminder for you of how to do the graphing of pairs. Let me start off here with 3, 2. Now remember, when you're dealing with an ordered pair, it's always x and then y. So your x-axis is your horizontal axis, your y is your vertical axis. When you're graphing these on 3, 2, let's start here, you're going to go over 1, 2, 3, going to go up 2 and make a point. Right, so you've all had experience doing that. 1, 0, you would go over 1 and then not go up or down at all because you have a 0 there for your y. Negative 1, negative 2. We go negative 1 and then down 2. And then negative 3, negative 4 would give you a dot right down here. Right? So you're going to be doing that. You're going to be doing the same thing that you've done in the past, but now what you're going to notice is everything's going to go in a line fashion. Now also, just as a quick reminder, this is set up into 4 quadrants, and they go counterclockwise. Quadrant 1, 2, 3, and 4. And you're going to hear about your x and y values and how those are impacted in what axis or in what quadrant they're in. Like right here, you would have to have a positive x and a positive y to have a point within quadrant 1. Now the only way to get to quadrant 2 is if you had a negative x and then you had a positive y value. And that would give you a point up here in this quadrant. For quadrant 3, you have a negative x and you would need a negative y. So you'd have a negative negative here. And then for quadrant 4, you'd need a positive x value and a negative y value. So if you see any questions pertaining to that on a test, or essentially this would be preparation for a placement test, that is what it's referring to. All right, next we want to talk about graphing using ordered pairs when you're working with an equation. So right here I've got y equals 2x minus 2. If you ever run into this scenario, and you will, what you want to do here is you want to choose x values that will give you a y output. So in essence, x is your in and y is your out. So if I put a 0 in for x, which is always the best place to start, what that's going to give you is y equals 2 times x, which is 0 minus 2, and 0 minus 2 gives you a negative 2. Then put a 1 in. So in this case, y equals 2 times 1 minus 2, which is 2 minus 2. So your y will be 0. It's a good idea also to get in the habit of putting negative numbers in, not just positive numbers. So if you put a negative 1 in for x, you get y equals negative 2 minus 2, which is negative 4. And then I'm going to go ahead and put a positive 2 and a negative 2 in as well. If you put a positive 2 in for x, and y equals 4 minus 2, which is 2. Then you put a negative 2 in for x, and you get y equals negative 4 minus 2, which is negative 6. So when you plot those, y at negative 2, there's your 1, 0, negative 1, negative 4, 2, 2, and negative 2, negative 6. You should notice, let me see if I can get a somewhat straight line here. You should notice, oops, I missed, that you do have a line that's formed. And that's why we're working with what's called linear equations. There will be not lines, but you'll have parabolas later on in the year where you'll have curves on your graph, but not in this unit, not in this chapter. Right, so this is called a table of values, and most of the time you just make a quick tree, just x, y. You'll have the equation above it, and you'll enter in your values. Occasionally those values will be provided for you, like you might have an x of 0, and then you have to come up with your negative 2. All right. Right, next example is a finding mathematical slope. Now, once again, on this, we had already filled in our values here. So when you're finding mathematical slope, let's put the 0, -2 back in. Let's put the 1, 0 in. -1, -4. And 2, 2. We'll just stick with those four. When you're finding mathematical slope, what you're finding is the steepness of that line. Let me plot a couple of these back in here and put the line back in. Got close. There we go. So here's what the line would look like. Now when you're finding mathematical slope, what you're finding is this, the steepness of this. How steep that is equals slope. Now there's a couple of formulas for this. I like to just call that the change in y over the change in x. And a lot of times I will just put y over x just to keep myself straight of what slope is. There's also a formula that you're going to see that looks like this. It looks confusing, but it's not. So let me show you how this comes to be right here. If you choose a pair of these points, say 0, -2, and 2, 2, just choose the first and last one. We'll call this coordinate pair 1. We'll call this coordinate pair 2. What you're doing with this is the little 1 here, the subset. It's not an exponent, it's a subset number. It means that it's the y from the first pair. Let's see, I actually put this in wrong. Pardon me, let me change that over to an x. And this means that's an x from the first pair. So this is going to be x1, y1. This one would be x2, y2. So it's y minus y. The thing you've got to make sure you do is if you're starting here and you're subtracting this one, then underneath you've got to start here and subtract this one. Right? You have to do it in the exact same order on both. So if I wanted to convert this into numbers, I'm going to choose the second y, which is 2. I'm going to subtract the first y, which was -2. And watch your double negative signs. That's an easy place to get mixed up. Underneath that, I'm going to start back at my second pair with my 2 here. And I'm going to subtract the first x, which is 0. Now 2 minus -2, that's the same as saying 2 plus 2. So that's 4. Underneath you've got 2 minus 0, which is 2. And with slope, a lot of times you'll have a fraction, and that's fine. But if it goes to a whole number, as this does, 4 divided by 2, your slope will just be 2. Right, so this is the slope of the line that you see graphed on this page. The slope is 2. So that's your mathematical slope. Now let's say I switched this around and I wanted to, let me get my eraser. And I wanted to reassign these backwards from what it was. So instead of this being the second one, let's call this the first pair. We'll call this the second pair. What I want to show you is that I'm still going to get a slope of 2 regardless, as long as I start in the same place and I'm consistent in how I do it. Alright, so if I'm taking the second y, in this case, my second y, complete that too, is -2. And I'm going to subtract the first y, which is 2. Underneath that, now my second x is 0. And I'm going to subtract my first x, which is 2. What I'm going to get is -4 on top, and then a -2 on the bottom. You know a negative divided by a negative is a positive, so these cancel out. And 4 divided by 2 is still 2, so I get the same slope. So finding mathematical slope, that's what you're working with. And it doesn't matter which pair of these points I pick, I'll always get a slope of 2 if I do my math right. Now a positive slope means from left to right, that line will go up. Okay, so it's a positive slope. A negative slope from left to right, that line will go down. And you'll see that again as we do more examples. At the next page, finding slope from a graph. Now I've got the same equation we're working with, y equals 2x minus 2. And if I want to find that from a graph, if I don't have these points given to me here, I can still find the slope without actually doing the mathematics. What I want to do is find how much my x and how much my y change. Going left to right, pick a couple of points that you can recognize on the graph. Like this one right here is -1, -4. And this one right here is +2, +2. Now you already saw in the last example I could do 2 minus -4 on top. And underneath of that I could do 2 minus -1 to find my slope, which gives me 6/3, so my slope is 2. What I can also do if I'm given a graph is from here to here is my change in y. And I've gone up 1, 2, 3, 4, 5, 6. Up 6 means I went +6 up. And that's my change in y. And my change in x, I went over 1, 2, 3. So this is my change in x. This was my change in y. And remember I said slope is change of y over change of x. So if I put the change of y that I counted in as a 6, if I put my change in x in as a 3, I get 6 divided by 3, so my slope is 2. Now where we're going next is I'm going to show you y equals mx plus b, which is the slope-intercept form of a line. And you'll note that when it's in y equals mx plus b, and I'll explain what those letters mean in a minute, m is your slope. And you'll note here in the equation that 2 comes before x, and 2 is the slope that we found on both the graphing version of finding slope and the mathematical way of finding slope right there. Alright, so moving on to that slope-intercept form. M is slope, and that is the steepness of your line, and whether it goes up, whether it goes down. Let me explain what these other letters are since we're here. Your B in this case is going to be your y-intercept. Now to figure out what that means, so here is your y-axis. The y-intercept is where the line is going to cross this particular axis. Your x and your y are your ordered pairs. So when you're given a point, you can plug that in. Now most of the time that is left empty. Alright? But you will use that when you're trying to write equations and lines, and we'll do that, I believe, at section 3. Alright, now let's look at that previous example again. I said that B is your y-intercept, and in this equation it's -2. Now if you look at where this does cross the y-axis, here we are at 0, -2. So -2 is our y-intercept, and our slope was found at 2. So we'll try to make that come together a little bit later. Alright, so on here, just try to remember as we keep going, and I'll remind you again, here is your y-intercept, your slope comes before x, as long as it's in this format, but it must be in slope-intercept form for that all to hold true. Okay? Alright, that's it for lesson 1, just quick introduction. So in the next lesson, you're going to graph using slope-intercept form, which you already got a preview of, convert equations to slope-intercept form if they're not already in that format, and find a slope from a graph of a line. Alright?